Hi, this is Introduction to Module 6 Lab, or the second lab, the specific heat of a metal. And you can pick any metal that you'd like. As long as you know what the metal is, you're going to have to write the metal used and the source of the metal. You can pick aluminum, you can pick iron, you can pick lead, whatever you'd like, but just make sure that you write it down. And then what you're going to do is take your metal and put it in a boiling pot of water and leave it there for 5 minutes so that the temperature of the boiling water becomes the temperature of your metal. That is important because here in this table it's going to be, so the temperature of boiling water is going to also be the initial temperature of your metal. You are going to measure that because we know that water boils at about 100 degrees Celsius, but it may be a little more or a little less. So make sure that you use your thermometer and you measure exactly what the temperature of the boiling water is and record that in the table over here. Okay, that will also be the initial temperature of your metal. And then what you're going to do is take your little coffee cup and you can take 50 milliliters of water and add it to the cup. Once you have added it to the cup, then take your thermometer once it's cooled off from measuring the boiling water temperature and measure the temperature of the water in this coffee cup. Once you have measured that so it doesn't change anymore, you are going to enter that as the initial temperature of water in calorimeter, or the coffee cup here. You're going to enter the volume, so about 50 milliliters of water, and the initial temperature that you measure here. Then what you're going to do is, please use caution, but take tongs and grab the metal from your boiling pot of water. Work quickly because you don't want to lose a lot of heat. You want to minimize the heat. And you're going to dump, make sure you don't splash, dump the metal inside that 50 milliliter of water. If you can, I would take another coffee cup and cut it so it fits inside this coffee cup as a lid. Make a little hole in it so that you can put the thermometer inside, and then measure the temperature of the water once you have mixed the water and the metal. The temperature of the water inside is going to increase a little bit because you have a hot metal and the water is cooler. So the metal is going to transfer heat to the water in the cup, which is going to cause its temperature to rise. So you measure, you watch the temperature. Once the temperature reaches the highest point that it does, and it doesn't change anymore or starts to go down, record the highest temperature that it reached. That is the final temperature for both. So the final temperature of the water in the calorimeter, but it is also the final temperature of the metal. Okay? So you will have 3 temperatures to measure. The temperature of the boiling water. You're going to measure the initial temperature with just the water in here with no metal. And then once you add the metal, you're going to allow them to reach equilibrium and then measure the temperature. Once it doesn't change anymore, that's going to be the final temperature of the water and the metal. Okay, then how do you go about filling out this table? The mass of the water is going to be the same as the volume of the water because we're assuming 1 gram per milliliter density. Okay, so these two numbers are going to be the same. And then the change in temperature of water is going to be the final temperature of the water minus the initial temperature of the water in the calorimeter. That's going to give you the change in temperature. Then the change in temperature of the metal is going to be the temperature of the boiling water, or the initial temperature of the metal, minus the final temperature of the water. It's going to be a negative value, but that's okay because the heat that the metal gives off is going to be also a negative number, which takes care of that. Okay. Then you're the specific heat of the water is actually a number that is, it's a literature value that is given to you. It's a constant. The heat energy absorbed by water, you're going to calculate that, and it's going to be equal in amount but with opposite sign as the energy that is lost by the metal. Then from that you can calculate the specific heat of the metal. The literature value, you have a table here, so if you find your metal down here, that's going to be the specific heat, and it's going to be the literature value. So you are going to calculate the percent error. So how close did your measured specific heat from the experiment compare to the literature value from this table? If your metal is not on this table, you can do a search on Google and find specific heat for fill in the blank, whatever your metal is. Okay. Once you've done that, you have post-lab questions, and they are exactly similar to the same calculations that you will be doing here, just to give you some more practice. And the last question, that how would you verify your prediction of the identity of the element, I want you to pick a different type of experiment. So do not pick, well, I'll redo this experiment. That is not how you want to independently verify your conclusion. So pick a different type of experiment or evidence or physical properties or chemical properties that you could figure out how to identify this element. Now I will make another video that will show you how to do the calculations. That will be part 2. This was just to show you how to fill the table. If you don't have trouble with the calculations, by all means, you don't need to watch the other video, but I will make one just in case. And if you have any questions, just let me know as always. Thank you.